Wi-Fi is like magic in the air, except it's actually not magic at all. It's very real, it's very technical, and sometimes very messy. Now, today I want to tackle two of the most common questions I get from my customers.
And the questions are, should I upgrade to the latest and the greatest standard, which is Wi-Fi 6, 6E, or 7 onwards? And the follow-up is, will all the upgrade solve all the problems that I've been having with my Wi-Fi? It's a simple question, but there's a complex answer. But before I answer that, I'd like to take a step back, way back. Let's go 25 years ago. Now picture an office where each desk had a big bulky tower and a computer all connected through Ethernet cables, either running under the carpets or on the walls. Wi-Fi isn't a thing at this point. Now, if you needed a software upgrade, you're looking for a CD to upgrade that software. In the hallway, you have a server room. It's the sacred temple, which is air conditioned. That's where all the data lives. Mobility, non-existent. You stayed at your desk. We didn't expect speed or mobility. We were happy if it worked. Now let's fast forward to today. Welcome to the modern office. There are no cables, very less local servers. Most important, there's no patience. It's Wi-Fi first. Actually, it's Wi-Fi only. All our apps are hosted in the cloud, or most of them. Our backups are automatic. If I have to get a push update on my certain app, it's pushed via the air. And if Wi-Fi goes down, well, the office pretty much stops. Our users are expecting fast, seamless, and flawless experience everywhere, all the time, for all their devices. Expectations have skyrocketed. And Wi-Fi wasn't originally designed for that kind of load. Let's look at some of the fundamentals here. The first fundamental I would like to point out is it's a shared medium. Because it's an unlicensed band, you don't pay for the frequency when you use Wi-Fi. You have to share it with your neighbors. If I take an example of my neighbor, I have a separate ISP, so does he. But if we use Wi-Fi and let's say we end up on the same channel, only one person will talk at a time. That's the second point, because that's how at the core Wi-Fi is a half-duplex system. So if I am connected with my laptop to my access point, or router some people might call it, which is wrong, you will be only able to talk if nobody else is talking. If my neighbor has the same setup, if I'm talking, he can talk in spite of having separate ISP. The next point is, if one person talks at a time, then who talks? Well, that will be decided by a roll of a dice, which really means is you roll a dice, everybody who wants to talk, you get a certain number. You count the number in the reverse. Once you get to 0, you take a little pause, and then you start talking. Now, if you think about Wi-Fi communication, think about how we humans talk. Generally speaking, most people are polite. They don't want to talk over each other. So in order to avoid that, you listen. Is anybody talking? Well, no. Okay, nobody's talking. Let me take a pause. Is it still nobody talking? Well, yes, nobody's talking. Okay, then I talk, right? So it's pretty much similar. Now, again, I have oversimplified here, which I'm usually guilty of, but that's the point. There are certain ways how this gets decided. If you want to go dig deeper into that, understand the DCF, how does that work, how the random back-off timers work, and how are all the interframe spaces work, that will give you more detail. Now, going forward, these are some of the fundamentals that Wi-Fi works on. If you take a look at the standard, right, there's a big shift over time. When you look at Wi-Fi 4 and 5, they were focused on throughput, faster speeds, bigger pipes, which really means bigger channel widths. But then the point is, it's not that one person wants to talk a lot. The point is there are a lot of people who want to talk a little, but there are a lot of people. So how do we make that happen? That's where they start to change the focus, and they said, let's look at efficiency now, right? Because in a crowded environment, it does not matter how big the pipe is if everybody is still trying to just shove the packets in at once. We need a smarter ways to share the air because it's a shared medium. If you look at some of the enhancements that came, the first one, I think the big one was OFDMA. OFDMA is not a new technology. It's been there for a long time in the cellular world. Wi-Fi world, it came for the first time when Wi-Fi 6 came on. What does that really mean? What does it really do? Now think of a use case where you have an elevator and there are three people waiting that need to use the elevator. Now, if the rule says only one person takes the elevator at one time, the other two will be waiting till the first one goes and then so on. You get the point. It's unnecessary wait there. But what if I told you that there is a way of putting all those people in the same elevator and sending them up at the same time? That's what OFDMA really does. It takes the channel, divides it into smaller resource units where you can have multiple people use it at the same time. What's the benefit? Well, if you fill the elevator with more people, it's obviously more people get delivered to their destination or the packets in this case, and it's fast and obviously efficient. The second thing I want to talk about is the BSS coloring. BSS coloring, if you think about this, me and my neighbor example, I go back. Let's say we are neighbors, yes, but his Wi-Fi signal is kind of weak in my house and mine is weak in his house. But because we're on the same channel, we were having that issue of one person talks at a time. But BSS coloring, it's able to identify that this is the red house, that's the purple house. They can let them talk together even if they're on the same channel. So taking that analogy into a meeting room, there were two meeting rooms side by side. Let's say in the one meeting room, there was a red team that were talking, and on the other one, there was a purple team talking. Now, the red team, they need to follow that rule where it is one person talks at a time. And then similar on the purple side, but they all can talk at the same time separately. Red team can have one conversation, so there can be two conversations going at the same time. So multiple talkers, which means we can have more conversations. Again, we're driving more efficiency into the system. The last thing that really came out was the target wake-up time. If you're not aware of this fact that most of your Wi-Fi client devices, your phones, your laptops, they have this habit of dozing off so they can conserve the battery. So they don't, because in Wi-Fi, they have to listen for all the packets, especially is anything coming from me or no. But if I was all the time and listening all the time, the battery life will be very less on the phones. And I think that I was reading some stats that if the phones were on all the time, with today's batteries, most phones will die in a couple hours, which usually doesn't happen, right? Because they have this concept of dosing. Now, let's take an analogy of somebody trying to take a bus. Now, let's say if you had no clue what time a bus is going to come, you had to keep going and checking, is the bus there? Is the bus there? It's pretty inefficient, right? That's what used to happen, I would say, pre-Wi-Fi 6 or pre-TWT time, where we had to do the PS poll thing. Now you have a schedule, which means you know exactly at what time the bus is going to come. You get up at that time, you reach the stop, you take the bus, you get your destination, right? That makes much more sense this way. If you have the bus schedule, which really means there is no more checking. So efficiency is not just speed, that's the superpower that the Wi-Fi 6 onwards and the newer standards bring on. If you look at, I've answered the first question. Yes, you should go for Wi-Fi 6 and above because it does drive efficiency. But I've not answered the problem two here, which means is if I do that, will it actually take care of the problems or will it solve all my problems? Let me put it this way. See, Wi-Fi is complex. There are a lot of knobs to turn, channel planning, power levels, roaming behaviors, interference, device support, band steering, RSSI, signal and noise ratio, different antennas, the list goes on and on. Now, if you compare that with a wired network, it's pretty simple. It's on and off. Is it on? Is it off? Straightforward, right? Now, Wi-Fi is like managing an orchestra, which means each knob has to be tuned just the right amount in order to get the best out of that Wi-Fi system. Now, let me take you and give you an example of my personal life here. I have this dog. He has this very interesting habit that if I give him a boiled egg, he will not take it. He loves the boiled egg, by the way. He will not take it. He likes his boiled egg when it's broken. Now, if you watch this, he enjoyed the egg. He took it only when it was broken. So you can't just throw a perfect egg at him because he's not going to take that. Wi-Fi is the same. It needs that customization. The newest tech, Wi-Fi 6, 6E, or 7, gives you the incredible raw capabilities, but unless you design and customize for your users, your environments, your devices, it won't deliver the result you're hoping for. The good Wi-Fi isn't just plug and play. It's plan, design, validate, and then optimize. Now, personally, I love using tools like Hamina and Ekahau to plan and simulate networks before I even touch an AP. Now, survey your environments, understand your client devices, design your real world needs, not just data sheet promises. Now, because at the end of the day, technology is only as good as its deployment is. So there's no magic, just smart design. Thank you.
So should you jump to Wi-Fi 6, 6E, or Wi-Fi 7? Well, absolutely. Will it magically fix your Wi-Fi headache? Well, not really. Only if you design for your unique space. If today's video helped you rethink wireless, smash that like button, subscribe for more fun, no fluff networking tips. Thank you for watching. Keep those packets flowing, and I'll see you in the next video. Bye for now.